Okay, so let's have a look at exercise 3F, just a little bit of help on question 2 and question 3. So I'll go through question 2E and 2F. For each of those, you will have to sketch the graph of both functions that are stated. So in E, the functions are f of x equals x squared minus 5 and g of x equals 7x plus 13. Then you have to find the coordinates of any points of intersection, and then finally write down the solution to the inequality f of x is less than or equal to g of x. So this is a quadratic going through minus 5 on the y-axis because it's shifted down here, and it will cut the x-axis at 2 points. If you want to find out, you make that equal to 0, so that will give you root 5 minus root 5. This is a straight line. The point of intersection with the y-axis is 13, so this is not to scale, but that's okay, and it's got a positive gradient. So for the sketch purposes, you can sketch it like this. Not sure where it crosses each other, but we are going to find those points of intersection by solving simultaneous equations. So that's the sketch. Maybe put 13 here. Then we have, for part II, we are going to find the points of intersection. So we're going to solve them simultaneously. So we have two equations, y equals x squared minus 5 and y equals 7x plus 13, making these equal to each other. So effectively replacing your y's in the first equation by 7x plus 13, we are going to generate a quadratic function which needs to be solved. So factorizing these, you will have x minus 9 and x plus 2. You may wish to solve it in a different way, which is fine, for example using the formula. So the two x coordinates of the points of intersection are 9, so this one here will have x coordinate 9 and this one will be minus 2. There you go. So we need to find the y coordinates. So to find the corresponding y coordinates, let's use the equation, well, either of these will do. Actually, I'll use this one here. So 9 squared minus 5, so it's 81, take away 5, which is 76. And for the second one, y is equal to minus 2 squared minus 5. So it's 4, take away 5, which is minus 1. So actually this point here, my line should be really maybe doing this to be fair. But it doesn't matter. It's for the purposes of the sketch, it's fine. I'll put it here. Minus 2 minus 1. Okay. Now, we could still use our sketch. So let's actually draw the over the adapted line here. That's a better version of that other one. There you go. So there is one point of intersection and there is this 976 point. Okay, so now we've got to find when is f of x below g of x. So f of x is the quadratic. So when is quadratic below the straight line? So the quadratic is the curved bit, so it's below this part is below the straight line. So the solution to this inequality will be represented by stating all the values of x when it happens, because what it is here is we are asking when is x squared minus 5 less than or equal to 7x plus 13. And if you rearrange it and make it into a quadratic, you can pop it into the calculator and find the solution to check whether you are right or not. But from the graph, you could say that this happens for all the values between -2 and 9. So it happens for x's such that x's are between -2 and 9. There you go. Okay, like I said, you can go ahead and rearrange this one. X squared minus 7x minus 18 is less than or equal to 0. And use a calculator. Let me just get the calculator. So I found my calculator. Let's just have a look. We are looking for the option B. So scroll down with your cursors to get to B. Press equal. We want polynomial of degree 2. And we want ax squared plus bx plus c is less than or equal, so option 4. And the coefficients are 1, -7, -18. Press equals and you get the solution between -2 and -9, sorry, just like we've done it over here. Okay, so let's have a look at question F. So this time f of x is 7 minus x squared. G of x is 2x minus 8. If you sketch f of x equals 7 minus x squared, so this is an unhappy quadratic passing through 7. If you make f of x equal to 0, these are root 7 minus root 7 and root 7. And this one here is a straight line with a positive gradient that passes through -8. Like I said, it doesn't have to be to scale. Again, I'm not sure where it will cross well, this one is at 4. 4 is, if you make it equal to 0, so that's fine. Okay, so this is -8. So you can see that there will be another point of intersection with the curve and the straight line over here. So we've got 2 points of intersection. And when we are going to be looking for when is f of x below g of x, we are going to be looking for when is quadratic under the line. So you're not going to be looking at this part, we're going to be looking at this part because that's when it's under. But that's in a moment. Let's find those points of intersection. We are going to do this algebraically. So for I, point of intersection, we're going to make 7 minus x squared equal to 2x minus 8. So x squared plus 2x minus 15 is equal to 0. So if I factorize it, it's a nice factorization. You will have x is -5 and 3. So let's put x is equal to 3. Let's find the corresponding y coordinates. So let's use this equation for a change. So y is 2 multiplied by -5 -8. So that gives me -18. So this point here is -5 -18. And this, if I put x is equal to 3, we'll do 2 times 3, which is 6 minus 8. That gives me -2. So this point here has coordinates x is 3, y is -2. So the question is, for what value of x is f of x less than or equal to g of x? So when is 7 minus x squared less than or equal to 2x minus 8? Again, you can rearrange it and use the solver on the calculator, but we are going to use our graph to inform us when it's happening. But obviously, if you are rubbish at graphs, use the calculator if you can. So, and I say you can because sometimes you might just have graphs and you don't have the functions, you just might have points of intersection, so you still need to understand how to do it with the graphs. Okay, so we're talking about for all those parts of the curve, so these are the straight line is going to be above for all the values of x, all the way up to that point and all the way up to that point. So up to -3 and from 3 onwards. So x is less than or equal to -5, or x is greater or equal to 3. So these are the solutions to the inequality. Like I said, I'm not going to do that, but you can go ahead and use the calculator for that algebraic solution to check whether you're right or not. Okay, so let's have a look at question 3. So this time you are not asked to sketch anything, so everything you will have to solve will be algebraically, because it says find the set of values of x for which the curve with the equation f of x is below the line with the equation y equals g of x. So f below g means mathematically f of x is less than g of x. Okay, it doesn't say is equal, it is below completely, so I interpret it as strict inequality. So for part A, f of x is given to be 3x squared minus 2x minus 1, and g of x is x plus 5. So when is this less than x plus 5? So solve it. Rearrange everything on one side to keep x squared positive. So it's minus 3x and minus 6 is less than 0. You can happily divide an inequality by positive number without any worry. So we can divide everything by 3. And again, you can factorize this one. Always check. If you are rubbish at factorizing, you shouldn't really be. But if you are, you can use an alternative way of solving, which is perfectly fine. X is equal to 2, or x is equal to minus 1. Now this time, we do not need the y coordinate because we are working out the set of values of x. The set of x. So we only want x's, because if you look at this equation, doesn't have y's, it only has x's, so solution will be reflected by the values of x. So we're going to draw the smiley face on the quadratic inequality through minus 1 and 2. Less than means below, so that tells me all the numbers between minus 1 and 2. So in the set notation, you may prefer to write it like this. Let's look at f of x for part f. F of x is equal to 2 over x plus 1. And then g of x is equal to 8. So you're going to solve when f of x is below g of x, so it's less than. So 2 over x plus 1 is below 8. Okay, so this is a quadratic inequality, a hidden one, because how we've learned to do it in the previous section, whenever you've got x in the denominator and it's inequality, we've got to get rid of it, but you are not allowed to multiply by something that could be negative. So we're going to multiply through by x plus 1, that is squared. That way you're going to be certain that you are multiplying each side by positive number. So let's do it slowly. So the left hand side gets multiplied by x plus 1, and 8 gets multiplied by x plus 1 squared. Now when you multiply the left hand side, you've got x plus 1 in the denominator and one of the ones on the second fraction, which is x plus 1 squared over 1. That will cancel. So you've got 2 times x plus 1 is less than 8 times x plus 1 squared. You have to expand everything. You could actually divide everything by 2 at this stage if you prefer. Makes it a little bit easier. So you have 4 left from that. And let's expand this bracket. X squared, add 2x, add 1. So it's x plus 1 is less than, let's expand it, 4x squared, add 8x, add 4. Move the x and 1 across to get 4x squared, add 8 minus x, so it's 7x, add 4 minus 1, so add 3. that's going to be reading from that side is greater than 0 because you have 0 on that side. Okay, try and factorize it. So we'll have 4x, I think 3 will go here. Whichever way you want to, you can help yourself with a calculator. You can use the quadratic formula as well, but that's not a bad factorization. So you've got two solutions. X is equal to minus 3 over 4 and x is equal to minus 1. Smiley face. You've got minus 1 and minus 3/4. It's asking when it's greater, so you're choosing the two regions outside. So it happens for those parts. That's when it's greater above. So when does it happen? For the values that are below minus 1 and the values that are above 3/4. So x is such that x is less than minus 1, or, that's important, x is greater than minus 3/4. There you go. Again, you could pop it into the calculator and check whether you are right. So let's put 4. Obviously, you need to put the one with 0 on the other side. 7 and 3. Just a minute, I think I've got the wrong one because I need to change the settings, don't I? Options, let me just double check. Try again. Equals, we want order 2, but yes, that was greater that we want to pick, so option 1. So let's do it again. 4, 7 and 3. There you go. Now the calculator gives you those inequalities less than minus 1 and x is greater than minus 3/4. It's written that way, but with a comma. If you write a comma in the answer in your exam, you will lose a mark. You've got to put or. Either like or, if it's asking for set notation, you write it like this, or if they don't specify, you can write a word or as well. I hope that helps.